So today we are going to discuss JEE Main September 2nd Shift 1 paper questions. So here see this question. A cylindrical container rotates with a constant angular speed omega. Radius of the cylinder is r. Find the height h as shown. So this is height h at which water is in equilibrium with respect to container. This is the question asked in examination. Now let us consider a small liquid element of dm at a distance x. A distance x, whose mass is nothing but what? dm. And this is radius. This is radius. It is this small liquid element is in circular motion. The centrifugal force acting on this small element is along this direction. That is dm into x into omega square. Dm into x into omega square. So here the weight of this small element dm into g vertically downward. If this angle becomes theta, this angle also becomes theta. Right. Now, the centrifugal force acting on this small element Fx is equal to dm into x into omega square. Weight of this small element acting vertically downward, Fy is equal to dm into g. This is equation 1, this is equation 2. Now, tan theta is equal to dy by dx. Slope tan theta is equal to dy by dx. That is equal here fx by fy. Fx by fy. Now dy by dx is equal to fx dm into x into omega square divided by fy dm into g. Here dm cancel. So dy is equal to omega square by g into x. Now when we integrate this equation, we get the height h. So now integrate this equation. Integration of dy is equal to integration of omega square by g into x. Up to what limits? From this point to this point. That means 0 to h. Now integrating this equation, omega square by g kept outside, from 0 to this maximum distance, that is the radius, 0 to r. So here y is equal to omega square by g into x square by 2, limits 0 to r. Now y, here the limits are 0 to h. Substitute the limits. H is equal to omega square by g, x is replaced by r square by 2. So at this height, the water is in equilibrium with respect to container. The water is in equilibrium with respect to container. So this is the problem. See, this problem is a cylindrical container rotates with a constant angular speed omega. Radius of the cylinder is r. Find height h. This is the height h. Omega square r square by 2g. So our correct option is omega square r square by 2z. This is our correct option. Discuss another problem here. In hypothetical spherical galaxy, the mass density is given by rho is equal to k by r. If the planet is rotating at a r0 distance from center of galaxy, find the relation between time period t and radius r0. So here this is spherical galaxy. Now this galaxy is treated as a solid sphere. Solid sphere. From the center of the galaxy at a distance r0, a planet is rotating. This is the center of the galaxy. From the center of the galaxy, at a distance r0, so a planet is rotating. A planet of mass is m is rotating. Right. Now this sphere is assumed as, this is a spherical galaxy. Combination of many uniform shells. Now let us take a spherical shell at a distance smaller. Spherical shell at a distance smaller, whose width is dr, thickness is dr. Right. So this planet is attracted by within this radius, within the shells of this radius. So it is not influenced by the outside shells. Right. The gravitational force between this center of the galaxy, that means mass of the galaxy is capital M and mass of the planet is small m, is F is equal to G capital M small m divided by r0 square. This provides necessary centripetal force for a planet, that is equal to m omega square r0 square. Omega square r0 square. Right. So here mass of the galaxy is equal to we integration of density into volume, integration of rho into dV. dV is the volume of this small spherical shell at a distance r. So m is equal to, we have to integrate from 0 to r0. To obtain the mass of the galaxy, we have to integrate from 0 to center of the galaxy to up to this distance, radius r0. 0 to r0 rho dV. 0 to r0 rho means how much? K by r. Here rho is equal to K by r. dV, volume of this small spherical shell. small spherical shell. So surface area pi r square into thickness dr. Now m is equal to 4 pi k integration of 0 to r naught r dr. So m is equal to, we get 4 pi k, this is r square by 2, 0 to r naught, 4 pi k, substitute the limits. So by substituting the limits, what we get here, r naught square by 2, r naught square by 2. So finally we get here mass of the galaxy is 2 pi k r naught square, 2 pi k r naught square. Substitute this value in this equation. So this is equation 2 and this is equation 1. Write G capital M, mass of the galaxy 2 pi k r naught square divided by r naught square is equal to m omega square r naught square, m omega square r naught square. Right. Sorry, here this is only r naught, m r omega square. So this is m omega square r naught square cancel. G into 2 pi k is equal to, what we get here, omega square into r naught. Here small m is there, G capital M small m by r naught square is equal to small m omega square r naught. Small m also cancel. Now omega square is equal to, what we get here, G into 2 pi k divided by r naught. Omega is equal to square root of G into 2 pi k divided by r naught. 2 pi k divided by r naught. Now we know that for time period formula, what is the time period formula here? Time period T is equal to 2 pi by omega. T is equal to 2 pi divided by, what is the value of omega here? Square root of G into 2 pi k divided by r naught. So here T is equal to 2 pi square root of r naught divided by square root of G into 2 pi k. So T is equal to what we get here, T is equal to square root of this root 2 pi, this is root 2 pi, is cancel in 2 pi, root 2 pi times 2 pi r naught by gk. So this is expression for time period. So our option is option 3. Stopping potential of emitted photoelectron is V when monochromatic light of wavelength lambda is incident on a metal surface. So what is the stopping potential here? That is V. If wavelength of light is incident becomes 3 lambda, then stopping potential of a photoelectron becomes V by 4. Then the threshold wavelength of a metal is K lambda. K will be. So this question asked from modern physics, very easy problem. We know that Einstein equation h nu is equal to half mv square plus w. So h nu is equal to half mv square e into v naught plus w. H nu means hc by lambda, that is equal to e into v naught plus w. Right. This is the equation 1. Whenever the wavelength of light lambda is incident on a metal surface. Now, if wavelength of light incident becomes 3 lambda, stopping potential of the photoelectron becomes V by 4. Then equation is hc by 3 lambda is equal to e into v naught by 4 plus w. This is equation 2. This is equation 2. Now, solving 1 and 2 equations. Here, equation 2 is multiplied with 4. Then what happens here? 4hc by 3 lambda is equal to e into v naught plus 4w. This is equation 3. Now, equation 3 minus equation 1. Equation 3 minus equation 1. 4hc by 3 lambda minus hc by lambda minus hc by lambda is equal to e into v naught cancel, 4w minus w, 3w. Right, we take common here sc by lambda. Sc by lambda, when we take common, 4 by 3 minus 1, that is equal to 3w. So here hc by lambda into this is 1 by 3 is equal to 3 into what is here w work function. Work function is equal to hc by lambda naught. hc cancel. So here lambda naught is equal to how much? 9 lambda. So here in problem they given threshold wavelength of a metal is k lambda. But here lambda naught is equal to 9 lambda. Compare this equation. Lambda naught is equal to here k lambda. By comparing these two equations, we get k is equal to 9. K is equal to 9. So our option is k is equal to 9. Now let us discuss another model. Here find the minimum value of F applied perpendicular to line OP. This is a force F. This line is perpendicular to OP, where OP is center of the ball of mass m and radius r required to lift the ball is. Now here what they ask, find the minimum value of F applied perpendicular to line OP to lift the ball. This is a force acting at a point. This force is acting perpendicular to the line OP. This force try to rotate this ball in clockwise direction. Here this is center of the ball and weight is acting vertically downward. Okay, and this is a line. So this line named as AP. this weight of the ball. The torque due to weight of the ball is in anti-clockwise direction. This torque is try to rotate in anti-clockwise direction. But to lift the ball, this torque must be F into R. Torque must be greater than or equal to mg into AP. So this torque may be equal to mg into AP or greater than mg into AP to lift the ball. Torque due to the force. So here F is greater than or equal to mg into AP by R. AP by R. Then here this is A, and this value is R minus A, and this is R. Now we want to find out AP. AP is equal to what we get here. This is a right angle triangle, R square minus of R minus A whole square. So AP is equal to square root of R square minus R square plus A square minus 2AR. AP is equal to R square minus R square minus A square plus 2AR. R square cancel. So here AP is equal to what we get here, 2AR minus A square. Substitute this value in this equation. So what we get here, F is greater than or equal to mg into AP value is equal to 2AR minus A square divided by R. So this is the value of force. When we apply this force perpendicular to the line OP, then the ball is lifting up. This this force is lifting the ball. So our answer is F is greater than or equal to mg into square root of 2AR minus A square by R. So our correct option is here. Check the options. This is the correct option. Now let us start another problem. Angular velocity of a smooth parabolic wire is y is equal to 4c x square about axis of parabola in vertical plane. If bead of mass m does not slip at A, B will be. So this is a bead. What they ask, this bead does not slip. Okay. What is the position of this bead at A, B? A, B. From y-axis, it has a distance A. So there is a centrifugal force is acting on a bead along this direction, m omega square A. So along the tangential direction, if this angle is theta, so this is weight acting vertically downward, weight of the bead vertically downward direction, and this is normal reaction. Now resolve this weight into two components. mg, if this angle is theta, and this component becomes mg cos theta. and this component becomes mg sine theta. Now resolve this centrifugal force. This is m omega square a. This becomes m omega square a cos theta. M omega square a cos theta. So for the bead does not slip, these two forces are balanced. M omega square a cos theta is equal to mg sin theta. Mg sin theta. Here m gets cancelled. Omega square is equal to g tan theta by a. Omega is equal, what we get here, omega is equal to square root of g tan theta by a. Equation 1. Square root of g tan theta by a. Now angular velocity, here the equation y is equal to 4c x square, they given. Y is equal to 4c x square. Differentiation this equation, dy by dx, that means tan theta is equal to 8cx. 8cx. What is the position of bead? X is equal to a. That is equal to 8ca. So substitute this value in this equation. Omega is equal to square root of g tan theta is equal to 8ca divided by a. That is equal to here 8gc. So finally we get here 2 root 2gc. So in the given options, this one is correct. Fourth option is correct. So this is a easy question, 2 root 2gc.